Hello everyone. This video would focus on conic section, specifically on parabola, and this is the third part. In this part, we are given the vertex, which is at 0, 0, or at the point of origin, and the two ends of the latus rectum, and we're supposed to sketch the graph. Before we go over this example right here, let's have a review on the basics of parabola with vertex at the point of origin or at 0, 0. There are four cases of a parabola with vertex at 0, 0, and this is the first case right here. Before we go over the details of the first case, let's have the parts of a parabola. These are the parts of every parabola. The first one is the directrix, which is represented as a broken vertical line right here. And this is the vertex. Again, our vertex is at the point of origin 0, 0. This is the focus, and this is the line of symmetry. Please remember that the distance from the directrix to the vertex is represented as P. So I'm just going to go ahead and label that up here. So this is represented as letter P. Now, the distance from the vertex to the focus is also represented as P. So this is another P right here. This tells us that for every point on the parabola, the distance from the directrix to the focus would always be the same. Meaning, if we take this point right here, the distance from the directrix and the distance from the focus, these two will be the same. And that is true for all the points on the parabola. Now, we also remember that if we draw a line perpendicular to the focus passing through the, or perpendicular to the line of symmetry passing through the focus, this is what we call as the latus rectum. So I'm just going to go ahead and label that up here. Now, we remember that the distance from the one of the endpoints of the latus rectum to the focus is 2p. And the distance from, again, the other end of the latus rectum and the focus is, again, the distance is 2p. So pretty much the length of the latus rectum is 4p. Now, we also remember that for every parabola, it will open towards where the focus is. So in this case right here, since our focus is on the positive x-axis, so the parabola will open on the right. Now, the formula that works for the first case is y squared equals 4px. So this is the formula for the first case. Now let's look at the second case. In the second case, the parts of the parabola would always be the same. We have the directrix, the vertex, the focus. This is the line of symmetry, and this is our parabola right here. If you notice, the parabola on the second case opens to the left since the focus is on the negative x-axis. Again, remember that the parabola opens to the side where the focus is. The formula that would work for the second case is y squared. It's pretty much the same thing as the first one. That's y squared equals 4px. So this is the formula that would work for the second case. Now let's move on to the third case. For the third case, the parabola opens upward since the focus is on the positive y-axis. We also have the directrix. Again, we have the vertex at the point of origin 0, 0, and we have here the axis of symmetry. Now, the formula that would work for the third case, again, whenever the parabola opens upward, is x squared equals 4py. So this is the formula for the third case. Now let's move on to the fourth case. In case 4, our parabola already is facing downwards. It opens downward because the focus is on the negative y-axis. And we still have the same parts. We have the directrix, we have the vertex, and we have the focus, and the line of symmetry is the y. The formula for the fourth case is pretty much the same as the third case. That is x squared equals 4 py. So this is the formula for the fourth case. So these are the four cases of the parabola with vertex at the point of origin, or 0, 0. Okay, going back to the problem here, we're supposed to determine the equation of a parabola with vertex at 0, 0 and with two endpoints of the latus rectum, so these 2 points right here, and we're supposed to sketch the graph. So let's plot these points on the graph here. So we say that our vertex is at 0, 0, and then we also have the first end of the latus rectum is -2, -1. So -2, -1, and the other end is +2 and -1. So we can go ahead and sketch the graph. So this is the graph of this problem right here. Now, looking at this graph, we can tell that this is case 4 since the graph is facing downward. So I'm going to go ahead and label that up here. So if this problem is case 4, we can go ahead and say that the general equation for case 4 is x squared is equal to 4py. But the thing here is we don't know what the p is. Remember, the p is the distance from the vertex to the focus, wherever the focus is in here, or from the distance from the vertex to the directrix, which is across from the focus. So we need to determine what the p is. Just by looking at this, we remember that the p is the midpoint of the ends of the latus rectum, which means that if these are the ends of the latus rectum, the middle between these 2 points, which is the midpoint, is the focus. So we can go ahead and say that our focus is actually located here. Since again, this is the endpoint, it's going to be 2 places to the right and 2 places to the left. However, we are supposed to show that it's really this point right here, which is at 0, -1 is the focus. And then again, this is our vertex right here. So I'm going to show here the method, or the algebraic method of determining the focus. We already have drawn it here, but we need to show it that it really at this point. So again, we remember that the focus is the midpoint between the 2 ends of the latus rectum. So I'm going to go ahead and write that up here. Okay, so we can go ahead and assign this as point F. So I'm just going to go ahead and label that as point F, which stands for the focus. Since we are going to use it's actually the midpoint between these 2 points, we're going to use the midpoint formula. So I'm going to go ahead and write that midpoint formula up here. So this is the midpoint formula. Now we remember that since we're talking about the 2 points here are the endpoints of the latus rectum, so we can go ahead and label this as our x sub 1, y sub 1, and x sub 2, y sub 2. So I am going to plug this value -2 for x sub 1, -1 for y sub 1, 2 for x sub 2, and -1 for y sub 2 to this equation. And so this will come out. Okay, so we have proven that our focus is located at 0, -1, and that's how it shows on the picture right here. Since we already have the focus, and the only thing that we need to find out in order that we can write the equation of this parabola is the p. Remember that the p is the distance from the vertex to the focus. Just by looking at this, we can already tell that it is 1. So the distance here is 1 because that's 0 and this is 1 right here. But let us show the mathematical method of determining the distance from the vertex to the focus, which stands for p. So I will show that work up here. Okay, so we are going to use the distance formula to determine the p. Again, the p represents the distance from the focus So the distance from the focus, which is at 0, -1, to the vertex, which is at 0, 0. Although we can already tell that this is 1 right here. The distance here is 1, but we have to show it mathematically. So then we go ahead and plug the values in. So the ones that we are going to put in here are these values. Again, remember, we are looking for the distance from the focus to the vertex. So we can have this as x sub 1, y sub 1, and x sub 2, y sub 2, and plug this into the distance formula to find for the value of the p. So this is how it's going to look like. Okay, the two values that we have here would be +1 and -1. Looking at this equation right here, we will take the p as -1 because the focus is going down, or the focus is below the vertex. So the +1 here stands for the distance from the vertex to the directrix, and the -1 here is the distance from the vertex to the focus. I'm going to go ahead and write that up here. Okay, so then we can go ahead and say that the value of p that we are going to use is -1. So we plug that -1 into this equation right here. So this equation would come out x squared is equal to 4 times the y. Again, remember our p is -1, and so I put that in there. So then the final equation that we can have then is x squared is equal to -4y. So this is the equation of this problem that we have up there. Now, we also remember that our directrix is located, it says here the distance from the directrix to the vertex, or from the vertex to the directrix, is 1. It's +1, so it's going to be above it. It's going to be here. Now, let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we're given the vertex at the point of origin 0, 0, and these are the ends of the lattice rectum. So we're going to sketch these points here. So the 0, 0 is our vertex. I'm going to label this as V. And then the ends of the lattice rectum is -9/4. -9/4 is 2.25. So that's going to be -2.25. So that's 1, 2, 2.25 is somewhere around here. And then that's +9/2. 9/2 is 4.5. So I go 4.5 up here. So this is where the first end of the lattice rectum is located. Now, the other end is on, again, -2.25. That's 9/4, somewhere here. And then the other coordinate is -9/2, so that's -4.5. So it's going to sit across that side right there. So these are the ends of the two ends of the lattice rectum. So then from here, we can go ahead and sketch the graph of this parabola. Okay, now we remember that the focus is located in the middle between the two ends of the lattice rectum. So it's going to be located here. This is the midpoint. So I can go ahead and plot a dot here, and this is going to represent our focus. Now, we are going to determine the coordinate of this focus. Again, we remember that this focus is the midpoint between the two ends of the lattice rectum. So I'm going to go ahead and write that up here. Okay, so I've written the formula for the midpoint, which is represented as the focus. Now we are going to label this as our x sub 1, y sub 1, x sub 2, y sub 2, and we plug this into the equation. So this is how it's going to look like. Okay, so the coordinate of the focus is located as negative 9 over 4. 9 over 4 again is 2.25. So that's 1, 2, 2.25. And then the y is 0. So we already have proven that this is actually our focus using the midpoint formula. Now we are going to determine the distance from the vertex to the focus. Although we can already tell that this distance here is negative 9 over 4 because that's going to the left, but then we go ahead and show the work using the distance formula. So then I am going to show the work down here. So after I plugged in the value of x sub 1, y sub 1, x sub 2, y sub 2 into the distance formula, we got this value right here. So there are two values here because then again, the other value of P is the distance from the vertex to the focus, and the other value of P is the distance from the vertex to the directrix. So I'm going to go ahead and write that down here. So then our value for P is negative 9 over 4. Now, looking at this equation right here, this is an example of case number 2. So I'm going to go ahead and write the equation for case number 2 right here. So we are going to plug in the value of negative 9 over 4. Again, we pick the negative. There are two values of P. The other P value is actually across, which is the directrix, and the other P value is the value or the distance from vertex to focus. So we're picking the negative here because it's going to the left. So we plug in the value here. So that would be y squared equals 4 times x. Again, our P is negative 9 over 4. So this gives us an equation of y squared is equal to, we can cross the 4 and 4. So that is negative 9x is the equation of this problem and the equation of this parabola that we have here. Now we can draw the directrix. The distance of the directrix from the vertex is positive 9/4, or again, remember 9 over 4 is 2.25. So that would be 1 to 2.25 is somewhere around here. So this is our directrix. So we have solved this problem up here. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!